Hello everyone, welcome to Knowledge Hub by Sri Chaitanya. And I also welcome you to these live sessions where we are discussing this chapter of stoichiometry. In the last class, I discussed about the mass concept, right? But in today's class, we are going to move ahead of that and use that concept in calculating the percentage composition and also find out the empirical and molecular formula. So this is what we had done in the last class. So we are going to move forward and move to today's topic. Right. So percentage composition is exactly same as you calculate percentage in your normal day-to-day life, like the percentage of marks that is calculated for you. Now let's get started for that. So percentage composition. So normally when you have some marks in your class, right, in a particular subject, suppose the maximum marks is how much? So maximum marks will be 100, right? And if out of 100, suppose marks obtained is 60, then percentage of marks will be 60 divided by 100 multiplied by 100, right? And this will come out to be 60%, right? So that is how we calculate marks, right, in your examinations, right? So this is the actual formula. So whatever you have obtained, you will put it in the numerator. The maximum amount that can be obtained, you put it in the denominator and multiply it by 100, right? So if you see here also the formula is similar. So you have the mass of the element in the compound divided by, like there it was total marks, now it is total mass of the compound, or I can say molecular mass multiplied by 100, right? So to give you a feel of this, let me take an example. Right. Suppose let us take the example of H2O, right? Now talking about H2O, I am also feeling little thirsty, so let me have little water. So in H2O, if I ask you what is the mass percentage of oxygen, right? What is the percentage of oxygen? How will you find it? You can see we have one oxygen here, right? And the mass of oxygen is what? 16 grams per mole. Right? And what is the total mass of water? Well, you have two hydrogens, so 2 grams for that, and you have one oxygen, 16 for that, you have 18 grams per mole, and you multiply it by 100, right? So you have, right? So whatever answer you get here will be your percentage of oxygen. So in this way, you proceed forward and calculate the mass percentages of any element in any formula. Suppose you have SO2. If I ask you the mass percentage of sulfur here, how will you do that? Simply molar mass of sulfur divided by molar mass of SO2 and you multiply it by 100. So that gives you the percentage of sulfur in SO2. So it's as simple as that, right? Now let me see if I have a question for you or not. Yes, I have a question for you, right? I want all of you to read this question carefully and try and arrive at an answer. I'm giving you some time. Read this question carefully, pause this video for a little bit and try and solve this question. So first let us decode the English language which is written here. You can see you have an oxide of sulfur. So an oxide of sulfur is there, right? Okay. That oxide contains 66.67% of sulfur. Okay. You have to determine its molecular formula. Now this is not a direct question. Understand that? It's not directly asking you the percentage, but the percentage is given to you. So if I say if I write the formula of this like percentage of sulfur, it will be mass of sulfur, molar mass of sulfur divided by molar mass of sulfur oxide, right, multiplied by 100. Now the very first thing that you need to do is let formula of oxide be SXOY. Right. Let this be the formula. Right. Now, if this is the formula, see each sulfur. If this is the formula, then percentage of sulfur becomes what? X into mass of one sulfur. What is the mass of one sulfur? Try and recollect, 32 grams per mole. Right. And then you have the molar mass of XXOY multiplied by 100. Now carefully see this formula which I have written here. Think about it. Has anything being given to you? Right. What is given to you in the question? See, this is given to you, which is the percentage of sulfur. So we can substitute it here, 66.67, right, equals to this whole thing. Now 66.67 can also be written as, see, at this point let me pause for a little bit and highlight an important question solving tool. So what is that important question solving tool? See, sometimes you will get some values in decimals like this I have here. It is easier for calculations and also for understanding to convert those decimals into some easy fractions with which we can do our calculations and make those calculations easier. So that's why I've converted 66.67 into 200 by 3. Now if you do this, right, into 100. So this is the formula that we have right now. Now let us see how we can proceed further from this formula. Right. So what is this? See, you have X sulfur atoms here, right? You have X sulfur atoms here. So I can write it here as X into mass of one sulfur atom, which is 32, plus Y into mass of one oxygen atom, which comes out to be 16. Right? And if you add them up, then you'll get this. So I can substitute this somewhat here. Can I or can I not? I think I can. Right? So how do I do that? Simply so this is our next equation, right? So I can cancel out these zeros from here and here. Next, what I can do? I can cancel out this 2 from here. I'll get a 16 here, right? And okay, let me just do one more cancellation. I can take out 16 as common in the denominator, right? So I can write it as 1 by 3 16x 16 2x plus y into 100. I can cancel out 16. Okay, 100 is already gone, so not required here. So I want all of you to try and simplify this equation, right? Let us try and simplify this equation step by step. So if you cross multiply, you will get 2x plus y equals to 3x, right? That is what you will get. You take this 2x this side, you will get y equals to 3x minus 2x. So you will get y equals to x. Right. So after this, you won't be able to solve this question further. You won't be able to solve this question further because now what we need is you need options. Right. This is that kind of a question. Yes, the kind of a question where you cannot get an exact answer, but you can get a relation through which you can find an answer out of the question options given. Suppose the option is S2O6, S3O4, suppose SO2, and next is your fourth option S2. If suppose these are the options given to you and through your problem solving you have been able to get a relation here that y will be equals to x. You can see in the first option 2 is not equals to 6, 3 is not equals to 4, 1 is not equals to 2, only here 2 is equals to 2. So this is the correct answer, right? So this, there you have it, a different flavor of question, right? Where you are not getting an exact answer, but you are getting some relation which leads you to the correct answer. So you see the options and this is the correct option. Register this in your mind, note it down. Next we are going to do something else. Right. Now this is a nice question, right? Insulin everybody has heard about, right? What is insulin? Insulin is a hormone which is released in your body to regulate the levels of sugar. Whenever you have food or you have something sweet, sugar levels in your blood increase a lot. They say that spikes, and then insulin is released in the body to reduce that sugar level, right? This has no relation to that, but because insulin is there, so a good fact for you. Insulin contains, suppose, 3.2% sulfur by mass. You have to calculate the minimum molar mass of insulin. See, here you do not need to ponder your brain or torture yourselves to get the molecular formula of insulin. No, you don't have to do that. If you're doing that, you're going on a wrong path and you won't get to an answer. You will only get to some more confusion. So don't think about it. Just think about what is given to you. You have been given the percentage of sulfur. What is percentage of sulfur? Simply mass of sulfur divided by molar mass of insulin multiplied by 100. Right? So one more thing is there, we have to calculate the minimum molar mass. see, this minimum molar mass thing actually is indirectly telling you that to minimize the molar mass, how will you have minimum molar mass? You will have minimal molar mass when you have minimum sulfur, right? Because they have given you sulfur, so I think sulfur is the only thing that you can change, or it is variable in this formula of insulin. So if it's in the formula of insulin, you have minimum sulfur, then only you will have minimum molar mass. And minimum sulfur value means what? Not 0, obviously, there is some amount of sulfur. Minimum value will be equals to 1, right? The minimum value will be equals to 1, right? So if minimum value is equals to 1, what is the mass of 1 sulfur? 32. So it is 32. And then you have the molar mass here, multiplying it by 100. This percentage is easily given to you, right? 32 divided by 3.2, 3.2, remove the point, put it upside. So the mass comes out to be what? 1000 grams per, right? 1000 grams per mole. So normally, this percentage, we measure it with very advanced instruments. In those instruments, you will only get this percentage. Using this percentage, indirectly, we will calculate the molar masses. So all this drama and all this hard work is being done just to calculate this. So these numericals are very important, because maybe sometimes, somewhere, some scientist must have calculated this 3.2% sulfur and calculated the molar mass of insulin. So this numerical goes down in history as something which actually helped scientists for the first time calculate the molar mass of insulin, right? So that's a little bit extra. Now moving on to the subject. So the first part of today's topic was percentage composition, right? The second part is again something called empirical formula. Well, in the last session we calculated molar mass, correct? Now the next session also, the connective thread between both the sessions is molar mass, and the path to molar mass goes through empirical formula. Now what is empirical formula? Well, let me give you a head at that. See, suppose I have this thing, C6H6, right? This is nothing but benzene, okay? These are your hydrogens, and these are your hydrogen. You will learn about it earlier, right? So, see, this is the molecular formula of benzene. This is the actual formula. So, this is the molecular formula, or I will say the actual formula. This is the actual formula. Now, from this, I can get another formula which is called the empirical formula. What is the empirical formula? Well, you have this carbon and hydrogen 6:6 ratio, right? Simplify this ratio to the simplest whole number, means simplify it to whole numbers where you cannot simplify it further. Remember, I am saying simplifying it to whole numbers, not fractions, not decimals. Only whole numbers will work. So if you divide both sides by 6, suppose if you divide it by 6, right, this ratio, you will get 1:1. So this was, see, this was the ratio of carbon is to hydrogen. So if the ratio of carbon is to hydrogen is 1:1, I can write it as CH, C1H1, right? So this simplest whole number ratio containing formula is called your empirical formula. Okay. Now from this empirical formula, how you can get to this actual formula? Simple. You divide by 6, right? You multiply it back by 6, right? C1 H1 multiply it by 6. So you will get C6 H6. So this is your actual molecular formula, right? So this is actually some of the concept of empirical formula and how it is different from molecular formula. I started with the molecular formula, made it a simple whole number ratio, and from the empirical formula I gave you molecular formula also. So the thing is that you have to always simplify to simplest whole number ratio, right? So here are some examples like benzene I gave you, CH. Next example, if I see, let me just remove this, right? You have C2H4. Try and simplify this to the simplest whole number. How will you do that? You can see something common here, right? The ratio is 2:4. Divide all sides by 2, 1:2. I don't think so you can simplify it any further. Can you simplify it any further? Well, try it. If you divide it by 2, what you will get? More 1. Means what I am saying is divided by 2 both sides, you get this. What is this? This is 0.5. But the problem is this is now a decimal, right? This is now a decimal. This will not work. This is not empirical formula, but this is an empirical formula. So the empirical formula will be, this is carbon and hydrogen ratio, CH2, right? Similarly, you have this glucose. Let us try that also. Glucose is C6 H12O6. 6 is into 12 is to 6, right? That is the formula. Divide all the ratios by 6. 1:2:1. Can you divide it further so that we do not get any decimals? I don't think so. So the formula will be CH2. This is the empirical formula. And next you have water. Let us see that also. H2O, water. The ratio of hydrogen and oxygen is 2:1. And if you further divide it by 2, you will get 0.5 here. That is not possible and that is not reasonable also for now. So the empirical formula of H2O is nothing but again H2O. Right? Right, everyone? Now, let me pause for a little bit and highlight an important point here. What is that important point? Stay with me on this one. See, you are dividing it by 6 here, correct? If you divide it by 6 here, then to get the molecular formula, I can also multiply it by 6, right? That gives me C6H12O6 again. So this 6 is called a number n, right? Which actually, with which you can equate these formulas. Like this formula, if I see, right, what I can write is as CH2O 6 equals to what? C6H12O6. I can write this. Is it clear? I can actually write this. Now, this is what? This is your empirical formula. Multiplied by 6 becomes equals to molecular formula, right? From this we got this. Now I'll move further. Through this I am going to just derive a general relation. what is that general relation? Pay kind attention. So simply I can write this as empirical formula multiplied by 6 equals to molecular formula multiplied here, right? And then if I 6, but this division has to be not in terms of formula, it has to be in terms of mass. So this is molecular formula mass divided by empirical formula mass. This gives us the value of, right? And if you multiply the empirical formula mass by that n, you will get molecular formula. This is important and will be used in numericals. Be careful about that. Okay. Note this down and try and remember this. So this, all in all, this is simply empirical formula, nothing big. People get confused in this. There is nothing to be confused. It is just this, a simple whole number ratio of all atoms present in one molecule of a compound, right? That's what it is. Now empirical formula we have done with simple whole number ratio, and we know that if we multiply this empirical formula by a particular number, then we will get the molecular formula, correct? Right. So let us talk about the molecular formula. Obviously it represents the actual number of atoms in one molecule of the compound. It represents the actual number of atoms, the actual formula, the reality. Empirical formula is our imagination, but molecular formula is the reality, right? Like this example, the molecular formula of benzene is C6H6, where actual number of carbon atoms is 6 and H atoms is also 6. What was the empirical formula? Divided by 6 CH. This was your empirical formula, right? Right. Now here I have summarized some of the steps to find empirical formula. Now these steps right now will seem little alien to you, right? You won't be able to understand what these steps are talking about, but these things will become clearer as we move towards questions, right? So let me still read this out for you because it will be helpful in the questions that we are going to discuss, right? So the steps to find empirical formula, right? So normally in questions you will be given mass percentages, and from the mass percentages you will be able to find the empirical formula, right? I'll tell you why that is. See, normally when we discover a compound, when a compound is discovered, right? Suppose a compound is discovered, right? Discovered means what? Discovered means, suppose suppose there are many medicinal compounds present in plants, like you have curcumin in turmeric, right? Curcumin is present, curcumin in turmeric. Now this, when it was discovered, you have to understand that we cannot see atoms, right? We cannot see atoms. So we put this in a machine, right, which is the mass spectrometer. What that does is it tells you the percentages of carbon, hydrogen, oxygen, and also the percentages of nitrogen. These are what you have got now is, you have got mass percentages, right? And now from these mass percentages we will find them. First we will find first find empirical formula, and from that we will find molecular So that is the procedure that we do. So initially you will have mass percentages of all the elements with you in most of your questions. Now if you have the mass percentage, what you have to do is, suppose you have X percent, suppose you have 60% carbon, right, and you have 20% hydrogen and you have 20% oxygen, right. These are the percentages of mass given to you. The very first thing that you have to assume is, let compound total mass be 100 grams, right, total mass be 100 grams. So now treat all these percentages as masses directly, because now you have 100 grams total compound. In 100 grams total compound, carbon will be 60 grams, hydrogen will be 20 grams and oxygen will be again 20 grams. Now how to get moles from grams? You do remember that moles is mass in grams divided by molar mass. So next step is dividing these masses by atomic mass of the element. So divide the percentages by mass of an element to get the ratio of atoms, right. You will get to know this further as we simplify it further. Next, after you got the ratios, divide the atomic ratios of various elements with smallest value of atomic ratio to get the simplest ratio of various elements. Simplest, just put it here, whole number ratio. And finally, multiply. If you still do not get a whole number ratio here, then you do the next step, multiply the simplest atomic ratio by suitable integer to convert simplest atomic ratio to whole number ratio, and that gives you the empirical formula. Confused? Don't worry, this confusion will be clear as we take up the question. Right, let me just take up the question first. Yeah, this question. Right. See, in an organic compound, the mass percentage of carbon, hydrogen and nitrogen is this. As I told you, they will give you mass percentages. So you have to let total mass of compound be 100 grams, right. Next, you write this, suppose you consider it as grams. Next, divide them by their respective atomic weights. See, this is here, this line is here. So 40.57 grams divided by 12 gives you a value of around 3.38. 8.53 divided by 1 gives you 8.53, again by 14, 1.69 and 1.7. So these are the decimals. But remember, empirical formula is the simplest whole number ratio. These are decimals. So next what we are going to do is, we are going to do some mathematical manipulations to get these values in decimals, no, in whole numbers. So one of the mathematical manipulations that we do in maths is, if you have a number of decimals in ratio, you divide each of the decimal by the smallest number. Which one is smallest out of these? Yeah, this one. So this is your smallest number. This is smallest. So divide each of these ratios by the smallest number, that is 1.69. So this division line has to be here, here and here. Now let us check whether we are having integers or not. So if we divide by this, is actually 2 times, right? 2 9s are 18 and 2 6s are 12 and then 3 3 3 exactly cancels out. This one does not cancel out exactly, but we are getting again a decimal. Don't worry. This is still fine. This is 1 and 1.69 and 1.7 is approximately same. So this is also approximately 1. Remember, in this whole calculation, if you are getting the chance to somehow make decimal a whole number, you should take that chance and make it a whole number, right? So here 2 can be written as 2, right? See 5.02, see 5.02 is approximately just 5 only, right? We can take it as 5, right? We're going to take it as 5, just between you and me, we'll take it as 5. Now 1 is 1, no issue. This is also 1. So now finally we have the simplest whole number ratio of moles, right? Simplest whole number ratio of moles. Remember, this atomic ratio is nothing but moles, right? You're calculating the moles, right? And then simplest whole number moles. Now why does this moles work? Well, think about it. If you have H2O, it simply means that if this is 1 mole of H2O, it means that this 1 mole of H2O can be made from 2 moles of H plus 1 mole of O, right? So this is 2:1 molar ratio, you will get the same as the ratio of atoms in the complete compound. So this is what I have done. So what will be the empirical formula, everyone? See, carbon is 2, hydrogen is 5, nitrogen is 1 and oxygen is also 1. So the formula will be C2H5NO, right? See it again, C2H5NO. C2H5NO. So our job does not end here. So this is till now I was following the procedure to get your empirical formula. After the empirical formula is over, there is another procedure to get, which I skipped, molecular formula. So determine the empirical formula, we have done that. Calculate the empirical formula mass. Simply, if you have an empirical formula like this, how to calculate this empirical formula mass? There is 1 carbon, so 12 plus 1 forms 13. So this is the empirical formula mass. Determine the molecular formula mass. See, this molecular mass either will be given to you or some values will be given through which you can find this. So molecular mass is needed. See, I have already discussed about vapor density. Sometimes they will also give you vapor density. You have to multiply it by 2 to get your molecular weight. Next, I discussed about this. Remember this value of N, which is molecular mass divided by empirical formula mass. Once you have N, we know that this is true, or empirical formula by N, right? So let us do that next part also here. Empirical formula mass is what? See, 2 carbons, 12 plus 5 into 1 plus nitrogen mass is 14 plus oxygen mass is 16. Add them up, you will bound to get this value of 59, right? See, there is no units written here. I will always prefer to write this with units so that you never forget, right? For 1 mole of compound. See, this molecular weight, is it given in the question? If I just clear this out, it is given the molar mass of compound is 59. Yes, the molecular weight is given. Life has been made easier for you because they have given the molecular mass directly. Right. So molecular mass is there. See, they are the equal, right? So molecular weight divided by empirical weight, you will get 1. So simply, see, molecular formula was empirical formula N. Now since N is 1, so a molecular formula is equals to empirical formula, which is equals to what? C2H5N, right? So this is the complete procedure that you have to follow. Make a table like this, write the mass percentage, atomic ratio or calculate the moles, then simplest ratio and simplest whole number or moles, right? Now let us have a look at another question. See now, see if I go back to this, right, let me just clear this up, right. See here, we have done this first step, right? Divide mass of an element to get ratio, we got it. Right. Divide atomic ratio of various elements with the smallest value of atomic ratio, we did that, we get this in 1 minute. We got this. Let me just select the pen, right? We got this. And after this, we move to the empirical formula because at this point, we got the whole number ratio. We got the whole number ratio, right? But what if after dividing, see, after dividing like this also we did not get all, we get decimals, then what to do? Then comes to the rescue your next step. Convert the simplest atomic ratio into whole number ratio. How? By multiply the simplest atomic ratio by a suitable integer. By hook or by crook, multiply by any number you like, make it whole number ratio. That should be your aim. So let us take one of those questions. Here you have it. I've done the calculations already because it takes little time to get till all the decimals. So you have an inorganic compound which has magnesium, oxygen, sulfur and H2O, right? Okay, one more thing I did not tell you in the last question. See, they've given the mass percentage of carbon, hydrogen and nitrogen but not of oxygen. So how you will get the mass percentage of oxygen? Simply what? 1500, see total mass was 100, right? Minus, you add all these mass percentages, plus 8.53 plus 23.65 and you minus them, you will get the mass percentage of oxygen which is around 27.25, right? These simple things and tricks you should know. I don't think so it needs to be told. Right. You have magnesium, oxygen and sulfur and see this is something different. H2O is also there. You do remember, right? There are some salts, hydrated salts, do you remember? Right, there are hydrated salts like this one. Right. Copper sulfate dot 5H2O. 5H2O is water of crystallization. So it is kind of this compound, remember. So treat H2O as a separate unit of atoms. So magnesium percentage is here, oxygen is here, sulfur is here, H2O is here. The next step is to calculate the moles from this. How you will do that? Divided by molar mass. Magnesium is 24, oxygen is 16, sulfur 32, H2O 18, divide, get ratio. See which is the smallest number? This is the smallest number. See, what I feel is you don't have to go till these many decimals, right? This much is fine, I am feeling. Just 0.4 and 2.8. Just go till one decimal in this case. I know that after that you will get the answer. No need of doing this much calculation. So, which is the smallest number? 0.4 is the smallest number, right? 0.4 is the smallest number, divide by 0.4. I think here also, oh, life is still easy. Here also you've got directly by division the simplest ratios. You don't have to go further. The only difference is, see, this is your magnesium, this is your oxygen, this is your sulfur and this is your H2, right? So magnesium is 1, sulfur is also 1, oxygen is 4, but water is 7. So that's what we have written, right? Okay, so this is one more question. I think I've written the solution also. The empirical formula of glucose is CH2O. It is CH2O. If its molecular mass is 80, what is the molecular formula of glucose? See, this is a kid's question. After the huge calculation you have done, I think it was irrelevant to put this here, but still I have put it maybe. So you calculate the empirical formula mass, divide the molar mass by empirical formula, you get 6, multiply it, you will get the formula, right? I know this is easy, so I am going to breeze through it and go to this one. See, calculation of empirical and molecular formula from combustion data. So how do we go about doing this? Well, let us first balance this out and then move forward to solving this question. This equation is as it is not balanced. So let us just, I am going to write this down here. Cx Hy O Z. Okay. For now, I don't think you require this Z part. Right. Just take it as just first let us do it for Cx Hy, and then we will take the Z part also. Leave some space here because you will put the coefficients. So what do I mean by from combustion data? Well, I told you that we put it in some machine and we calculate the mass percentages, but that is not always the case. See, sometimes we also have another method where we take the sample and light it. We put it to fire, let it combust, and you know that every organic material will contain carbon and hydrogen, and when you burn them, what happens? You will get water, carbon dioxide and something unburned carbon. But here I will do complete combustion. So carbon will convert into carbon dioxide, hydrogen to H2O. So see, as many carbon atoms are there, that many atoms of CO2 will be formed. So you can put X here. Hydrogen is Y, but in this molecule we have 2 hydrogens. To make it Y hydrogens, I can multiply it by Y by 2, 2 cancels, you will get Y hydrogens. Now how many oxygen atoms are there here? Check. Remember, I am talking about oxygen atoms. So here is 2x plus Y by 2 oxygen atoms, right? Now suppose I put this coefficient as n, right? So how many oxygen atoms here? 2n. So the value of n will be x plus y by 4. So I can write this equation again as Cx Hy plus x plus y by 4 O2 giving you x CO2 plus y by 2 H2O, right? So this is the very first step. You should know how to balance it out, and after you know how to balance it out, you can move to questions. So write this down, and this is the way how you calculate it and how do you balance it out. Fine. Right. So now you have a question with you. So you have 3 grams of an organic compound. 3 grams of an organic compound when burned in excess of air gave 4.4 grams of carbon dioxide and 1.8 grams of water. So write down the equation first. Right. So you have 4.4 grams of carbon dioxide you get after burning, and you get 1.8 grams of H2. See, whenever you have grams, so the thumb rule is, or the hint is, always calculate it in moles. Because this equation tells you what? This equation tells you that if I go back, this equation tells you that 1 mole of this forms X plus reacts with these many moles of oxygen to give you X moles of carbon dioxide and Y by 2 moles of water. Right. So this equation represents this. Correct? So this equation is written in moles, interpreted in the form of moles. So whenever you have a question, you have to answer it by calculating moles. Right? So moles of carbon dioxide, how you will calculate? See, this is the mass. Next, moles, how you will calculate? Divided by molar mass of carbon dioxide. Carbon is 12. 12 plus 32 gives out 44. Water you know is what? 18. So you will get 0.1 moles here, 0.1 moles here. Okay? 0.1, 0.1 moles. So X and Y, how you will find? See, what are the moles of carbon dioxide that have formed? X moles. So I can say that X is equals to 0.1, correct? And Y by 2 is also equals to 0.1, right? So Y equals to 0.2. So I have the value of X and I have the value of Y. But we need the simplest whole number ratio. Correct, everyone? So how you will do that? So you have 0.1, you have X, Y, 0.2, multiply the whole by 10, 1 is to 2. Right? So now you have the empirical formula as CH2. This is your empirical formula. Correct? So you have the empirical formula with you. Now what about the molecular formula? How you will go about finding that? Well, for that, like if you have burned in excess of air to give, how you will calculate molecular formula? Yes, how you will calculate. Empirical formula is done, right? Molecular formula, how you will do it? Let us see this again. Let me take the eraser again. See, this will be the last question, I think. The time is almost up. Let me just solve this up. Right. See, I told you from 1 mole of this compound, you will get X moles of carbon dioxide. Right. X moles of carbon dioxide. Correct? So 1 mole is equivalent to X moles of carbon dioxide. Then, and what is X? 0.1 moles. Right? Right. So from 1 mole you will get 0.1 mole of carbon dioxide. So now 3.2 grams is how many moles? 3 by grams by molar mass of the compound, right? These many moles. So these many moles can give how much amount of carbon dioxide? How many moles of carbon dioxide? Or let me do it another way. See, let us just erase all this and let me make it simpler for you. See, we see 1 mole of CXHY gives X mole of CO2. Right? So how many moles do we have? 3 grams. So 3 grams by molar mass moles of CXHY will be given by how many carbon dioxide moles? Can you guess it? See, 1 mole X. So these many moles, 3 grams M into X moles of carbon dioxide. Right? These many moles of carbon dioxide you should get ideally. And how many moles of carbon dioxide you have actually gotten? What is the value of X? Right, 0.1, and the total carbon dioxide mole is 0.1, right. Let me just try and do it some other way. This also is not going to work. We have the moles of C2H5, X moles, gives you X moles of carbon dioxide. I think for solving this, we need some extra data. There is something missing in this question. I'll take it up in the next session and complete this up. For now, I want all of you to note down these questions, right? We're going to solve these questions as well in the next session, right? And these questions as well. So note them down, take a screenshot. In the next class, we'll solve all of these questions one by one, right? So now if you liked what you saw here, what you understood here, let's take a break and scan this QR code to get to know about more courses by Knowledge Hub by Sri Chaitanya and connect with us